When dealing with vertical conduit runs containing multiple conductors and tower lighting applications, several strain relief methods can be employed. Each approach offers distinct advantages, and the best choice depends on factors such as the number of conductors, conduit size, and environmental conditions. One option is to use a custom drilled conduit body. This involves drilling holes in a 1-inch conduit body that match the diameter of the conductors. Insert the conductors through the holes and secure them with lock nuts or sealing washers. It is important to ensure the conduit body is securely fastened to the tower. Another approach involves conduit straps with cable supports. With this method, install conduit straps at regular intervals along the conduit to prevent sagging. Use cable supports that mount to the conduit straps and provide strain relief for individual conductors. Look for cable supports designed for 1-inch rigid conduit. Thirdly, consider using neoprene drive-in plugs with holes. Locate or create a neoprene drive-in plug with multiple holes that match the conductor diameters. Drill a hole in the conduit and insert the plug. Push the conductors through the plug holes and secure them with zip ties or other appropriate means. Fourthly, investigate strapless conduit adapters. Install a strapless conduit adapter to the conduit at each lighting level. These adapters typically have integral strain relief for multiple conductors. Ensure the adapter is securely connected to the conduit and the lighting fixture. Fifthly, use split bolt connectors with cable grips. Use split bolt connectors to connect the conductors. Install cable grips over the split bolt connectors to provide strain relief. Secure the cable grips to the conduit using conduit clamps or cable ties. Several key considerations apply when selecting a strain relief method for tower lighting applications. Firstly, ensure that the selected strain relief method is Underwriters Laboratories or UL listed for outdoor and tower lighting applications. Secondly, use corrosion-resistant hardware and components that can withstand extreme weather conditions. Thirdly, provide easy access for maintenance and inspections. Fourthly, test the strain relief system thoroughly before energizing the lighting circuit. When selecting conductors for such applications, several factors should be taken into account. The conductor size should be determined based on the ampacity requirements of the lighting fixtures and in accordance with the National Electrical Code, or NEC. Chapter 3 of the NEC covers wiring methods and materials. Article 300.17 specifically addresses raceway fill. For a single conductor in a raceway, the allowable fill is 53%. For 2 or more conductors, the allowable fill is 31% for rigid metal conduit. It is crucial to consider the voltage drop in the conductors, especially over long distances. The NEC provides guidance on voltage drop in branch circuits and feeders. A maximum voltage drop of 3% in branch circuits and 5% in feeders is generally recommended. The type of insulation should be suitable for wet locations and exposure to sunlight and extreme temperatures. Types THWN2 or XHHW2 are commonly used for these applications. The number of conductors in the conduit must comply with NEC fill requirements. Refer to Chapter 9, Table 1 and Annex C of the NEC for conduit fill calculations. Remember, when running multiple conductors in a conduit, each conductor must be individually insulated. The insulation must be rated for the voltage and temperature it will encounter. In situations where multiple circuits share a single conduit, the NEC requires that all conductors be insulated for the maximum voltage present in any circuit within the conduit. For example, if a 480-volt circuit and a 120-volt circuit are run in the same conduit, all conductors must have insulation rated for at least 600 volts. When selecting conduit, rigid metal conduit, or RMC, offers excellent physical protection and is suitable for outdoor and wet locations. Intermediate metal conduit, or IMC, is a lighter weight alternative to RMC and can also be used in similar applications. Electrical metallic tubing, or IMT, is not typically used in tower lighting applications due to its lower strength and lack of threading. Consider using expansion fittings in long conduit runs to accommodate thermal expansion and contraction. The NEC requires expansion fittings where temperature changes are expected to exceed certain limits. Follow manufacturer's recommendations for spacing and installation. Grounding is critical for safety. The metal conduit system should be properly grounded to provide a low impedance path for fault currents. Use grounding bushings and bonding jumpers to ensure continuity of the ground path. According to NEC Article 250.4, electrical systems shall be grounded in a manner that creates a low impedance circuit facilitating the operation of overcurrent devices. Always consult the latest edition of the NEC and local electrical codes for specific requirements. Proper planning and execution are essential for a safe and reliable tower lighting system. Firstly, conduct a thorough site assessment to identify potential hazards and challenges. Secondly, develop a detailed design that meets all applicable codes and standards. Thirdly, use qualified electricians and technicians for the installation. Fourthly, inspect and test the system thoroughly before putting it into operation. The NEC requires that all electrical work be performed in a neat and workmanlike manner. Conductors should be properly supported and secured, and all connections should be made with approved methods and materials. Article 110.12 of the NEC prohibits installing electrical equipment in a manner that would prevent it from operating safely or efficiently. In addition to strain relief, consider other factors that can affect the reliability of the tower lighting system. These include lightning protection, surge suppression, and proper ventilation for lighting fixtures. The NEC contains specific requirements for lightning protection systems in Article 250.6. Surge protective devices, or SPDs, can help protect sensitive electronic equipment from voltage transients. These devices should be installed at the service entrance and at critical branch circuit locations. Proper ventilation is essential for preventing overheating of lighting fixtures, which can shorten their lifespan. Follow manufacturers' recommendations for ventilation and spacing. Regular maintenance is essential for ensuring the long-term reliability of the tower lighting system. Inspect the system periodically for signs of damage or deterioration. Replace any components that are worn or damaged. Keep the lighting fixtures clean and free of debris. The NEC requires that all electrical equipment be maintained in good working order. Article 110.3 outlines the requirements for examination, installation, and use of equipment. When working on tower lighting systems, safety is paramount. Always de-energize the circuit before working on any electrical components. Use appropriate personal protective equipment, including gloves, eye protection, and fall protection. Follow all applicable safety regulations and procedures. The NEC contains numerous safety-related requirements. Article 110.26 addresses working space around electrical equipment. Article 225.26 covers access to overcurrent devices. Article 240.21 covers the location of overcurrent protection. Tower lighting systems are often exposed to extreme weather conditions, including high winds, ice, and snow. Ensure that all components are rated for these conditions. Use corrosion-resistant materials and finishes to prevent deterioration. Consider using heat shrink tubing to protect connections from moisture and corrosion. The NEC contains requirements for wiring in wet locations. Article 300.6 requires that metal raceways be protected from corrosion. Article 410.10 addresses the installation of luminaires in damp or wet locations. Remote monitoring of the tower lighting system can provide valuable information about its performance and condition. Consider using a monitoring system that can detect outages, voltage fluctuations, and other problems. This can help you identify and address issues before they lead to more serious problems. Remote monitoring systems can be integrated with building automation systems or other control systems. They can also provide alerts via email or text message. When designing a tower lighting system, consider the aesthetic impact of the lighting. Use lighting fixtures that are appropriate for the architecture of the tower and the surrounding environment. Avoid creating glare or light pollution that could disturb neighbors or wildlife. The Illuminating Engineering Society, or WISE, provides guidance on lighting design and glare control. The NEC does not specifically address aesthetic considerations, but it does require that lighting be installed in a safe and effective manner. Consider using energy-efficient lighting technologies such as light-emitting diodes or LEDs to reduce energy consumption and operating costs. LED are more efficient than traditional incandescent or fluorescent lamps, and they have a longer lifespan. The NEC contains requirements for energy efficiency in Article 220.87. Many local jurisdictions also have energy codes that must be followed. When replacing existing tower lighting systems, be sure to dispose of the old components properly. Incandescent lamps and fluorescent lamps contain hazardous materials that must be recycled or disposed of according to local regulations. Contact your local waste management agency for information on proper disposal methods. The NEC does not specifically address disposal of old equipment, but it does require that electrical work be performed in an environmentally responsible manner. When installing new tower lighting systems, be sure to document the installation thoroughly. Keep records of all materials used, test results, and maintenance performed. This documentation will be valuable for future maintenance and troubleshooting. The NEC does not specifically require documentation, but it is good practice to keep records of all electrical work. Be sure to follow all applicable codes and standards when installing and maintaining tower lighting systems. The NEC is the primary code governing electrical installations in the United States. However, local jurisdictions may have additional requirements. Contact your local electrical inspector for more information. Regular inspections can help identify potential problems and ensure that the system is operating safely and efficiently. The NEC does not specifically require regular inspections, but they are recommended as a best practice. When performing inspections, look for signs of damage, corrosion, or overheating. Check all connections to ensure that they are tight and secure. Test the system to ensure that it is operating properly. Tower lighting systems are an essential part of aviation safety. They provide a visual warning to pilots of the presence of tall structures. Proper installation and maintenance of these systems is critical for preventing accidents. The Federal Aviation Administration, or FAA, has specific requirements for tower lighting systems. These requirements are outlined in FAA Advisory Circular 70/7461. Be sure to consult this document when designing and installing tower lighting systems. Remember to prioritize safety, compliance, and long-term reliability. When selecting components, choose products that are UL listed and suitable for the environment. When performing installations, follow all applicable codes and standards. When performing maintenance, be sure to energize the circuit and use appropriate personal protective equipment. By following these guidelines, you can ensure that the tower lighting system is operating safely and efficiently for many years to come. Remember that working at heights requires specialized training and equipment. Ensure that all personnel involved in the installation and maintenance of tower lighting systems are properly trained and certified. Fall protection equipment, such as harnesses, lanyards, and lifelines, must be used at all times. Regular inspections of fall protection equipment are essential to ensure that it is in good working order. In addition to electrical safety, consider other safety hazards, such as falling objects and inclement weather. Use appropriate barricades and signage to warn others of the work being performed. Monitor weather conditions and suspend work if necessary. Planning and communication are essential for a safe and successful tower lighting project. Develop a detailed plan that outlines the scope of work, schedule, and safety procedures. Communicate the plan to all personnel involved in the project. Hold regular safety meetings to discuss potential hazards and review safety procedures. By working together and following established safety protocols, you can minimize the risk of accidents and ensure that the project is completed safely and efficiently. Always refer to the latest edition of the National Electrical Code and any applicable local codes and regulations for specific requirements related to tower lighting installations. Electrical codes and standards are constantly evolving to reflect new technologies and best practices. Staying up to date with the latest requirements is essential for ensuring that the tower lighting system is safe and compliant. Remember, the information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. Consult with a qualified electrical engineer to ensure that the tower lighting system is designed and installed in accordance with all applicable codes and standards. A qualified engineer can perform calculations to determine the appropriate conductor sizes, conduit fill, and overcurrent protection. They can also provide guidance on grounding, lightning protection, and surge suppression. By working with a qualified engineer, you can be confident that the tower lighting system will meet all of your requirements and operate safely and reliably for many years to come.